Hello guys, welcome back to another video, and in this video we are going to talk about GPU in depth. So let's get started. So in the previous video we learned about CPU and GPU, the differences, but in this video we're going to learn about the GPU in depth. So as we talked about in the last video, GPU is the graphical processing unit, or what we often call as the graphics card. So computer graphics are an essential part of any modern computer system, even lightweight laptops. GPU stands for graphics processing unit, and it is a part of the PC responsible for the on-screen images you see. So basically, now let's know what does the GPU does. So if we use our computer for the basics to browse the web or use software and desktop applications, then much more we need to know about the GPU. It's a part of the PC that is responsible for what we see on the monitor, and that's it. But for gamers or anyone who does work that can be GPU accelerated, like 3D rendering, video encoding and so on, the GPU does much more work. So these people need to get a lot more out of the GPU. So let's dive in further. So GPUs were originally designed to accelerate the rendering of 3D graphics. Now over time they became more flexible and programmable, enhancing their capabilities. These allow graphic programmers to create interesting visual effects and realistic scenes with advanced lighting and shadowing techniques. Other developers also began to tap the power of the GPUs to dramatically accelerate additional workloads in high-performance computing, HPC, deep learning, and more. So going on, let's now know about the uses of GPU. Now there are a lot of uses of GPU, and if we categorize them, then we can say that GPU can be used for the high-end experience of playing games, or it can be used to do 3D rendering, and sometimes even used in machine learning and even crypto mining. So in video games have become more computationally intensive with hyper-realistic graphics and vast complicated in-game worlds. With advanced display technologies such as 4K screen and high refresh rates, along with the rise of virtual reality gaming, demands on graphics processing are growing fast. GPU are capable of rendering graphics in both 2D and 3D. With better graphics performance, games can be played at higher resolution at faster frame rates, or both. For years, video editors, graphic designers, and other creative professionals have struggled with long rendering times that dried up the computing resources and stifled creative flow. Now the parallel processing offered by GPUs makes it faster and easier to render videos and graphics in higher definition format. Some of the most exciting applications for GPU technology involve AI and machine learning, because GPUs incorporate an extraordinary amount of computational capability, and they can deliver incredible acceleration in workloads that can take high advantage of the parallel nature of GPUs, such as image recognition. Many of today's deep learning technologies rely on GPUs working in conjunction with CPUs. So now that we are in the 21st century, we see that there are cards that use this machine learning, and these cards mainly use the GPU to do such work. So advanced technologies such as object detection and machine learning can be done using GPU, because the acceleration and the time needed to do the computation is much better and faster while using a GPU. Similarly, when a person is playing a video game, a GPU is needed in order to get the best gaming level experience and it can render your video games in 4K screens and can even be used in VR gaming. And for video editors and 3D graphic designers and professionals, the video can be encoded and it can be done in much less time when you are using a high-end GPU. Now, the GPU uses mainly parallel processing, where multiple processors handle separate parts of the same task. A GPU also has its own RAM to store data on the images it processes. Information about each pixel is stored, including its location on the display. A digital to analog converter (DAC) is connected to the RAM and turns the image into analog signal so that the monitor can display it. Okay, so now video RAM will typically operate at high speeds. So basically what it does is that it takes your images and changes it into the analog signal using the DAC, known as the digital to analog converter, and then once it does that, the monitor can display it. Now the video RAM does this work at high speeds. Now GPUs come in two types, integrated and discrete. So integrated GPUs come embedded alongside GPU, while discrete GPUs can be mounted on a separate circuit board. So GPUs come embedded alongside CPU, and another can be mounted separately on a circuit board. For companies that require heavy computing power or to work with machine learning or 3D visualizations, having GPUs fixated in the clouds can be a good option. An example of this is Google's cloud GPUs, which offer high performance GPUs on Google Cloud. Hosting GPUs in the cloud will have the benefits of freeing up local resources, saving time and scalability. Users can choose between a range of GPU types, gaining performance based on their needs. So there are different types of GPUs, and on the basis of the needs, the user can choose any, like from a high-end GPU like the right now in the market, which is the RTX 3090, which is very costly and very expensive, or you can choose a very nominal GPU like the 1050 Ti or 1080, something like that. Moving on, let us now know about the integrated graphics. Now, integrated graphics is a GPU built into the processor. Okay, so basically when you have a GPU and a CPU together in a single chip, okay, so it is the fusion of a GPU and a CPU, and when this thing is done, the fusion chip is often known as the APU, or the accelerated processing unit. Now, accelerating processing unit is basically found in systems such as laptops. Okay, so the APU is a processor in contrast to specialized processor for graphics, voice, photos. The APU term is typically found on a system on chip which houses several different processing units. Now carrying on, discrete graphics. So discrete graphics is a GPU that is separate from the processor, and discrete graphics has its own dedicated memory that is not shared with the CPU. Now since this discrete graphics is separated from the processor chip, it consumes more power and generates a significant amount of heat. However, a discrete graphics has its own memory source and power source, and it provides higher performance than integrated graphics. Discrete graphics are most commonly found in desktop PCs, laptops, and small form factor PCs can also contain discrete graphics. So basically when we compare the discrete graphics and integrated graphics, we can say that integrated graphics contains a fusion of CPU and GPU, which we often refer to as APU, an accelerated processing unit, and it is found in laptops and small form factor PCs. But discrete GPU is something totally different. Discrete GPU has everything of itself, starting from a cooling system to its own RAM, and it consumes more power and generates a significant amount of heat, but it also provides you the better graphics and the speed when you are playing video games or doing 3D rendering or deep learning, whatever you are doing which uses the GPU. So now discrete graphics are in real world are much costlier than integrated graphics because of the performance they provide. And that's all. So this is all the things that you need to know about GPU